I do not use this test, but I need to present it to you. You may be interested in using it, so that's fine. Nothing wrong with it. So assuming that I find the first derivative, assuming that I find the critical numbers, but then you say, I don't want to study the sign of the first derivative. I don't care for the sign right now because I am going to find the second derivative, and based on the sign of the second derivative, I will find the local max and the local min of this function. The reason why I don't use it, it's obvious. And here it is. I may make a mistake in the first derivative, and I may not find it, not even after I find the second derivative. Who knows? I can't have that. But that's me. You can say, no, I like this test. I'm going to use it. And I will wish you good luck. It's fine. It's nothing wrong with it. But again, if I happen to make a mistake on the first derivative, I will carry it all the way to the second derivative, and it will be a total mess. So here's how we think. So assuming that I have the correct second derivative, assuming that I have the inflection point here, assuming that the function opens downward, assuming that the function opens upward, I'm trying to find what does negative 2, 72 represent, and 3, negative 53 represent. Well, the function looks like this. In the area where the function looks like this, there is a critical number. The critical number is negative 2. Well, the function looks like this, and there is a critical number. I know that this must be a local max. There is no other option. And if this is a local max, this must be positive, and this must be negative. There's no discussion. So once I have the sign of the second derivative, and I know that the function is concave up, and in that particular area where the function looks like this, there is a critical number, then I know the sign, left and right. And I know that this must be a local max. Coming back here. In this area, I know that the function looks like this. And there is a critical number. What could it be? The function looks like this according to the second derivative. And there is a critical number there. I'm done. This must be a local min. And this one is the IP. 1/2, 9.5 is the inflection point. This is called the second derivative test. If you like it, use it. If you don't like it, you don't have to use it. I'm not going to force you to. But this is how it works. So there are 3 things that the second derivative helps with. Number 1, I'm going to put them in writing. Number 1, it gives the inflection point. Number 2, it gives the concavity when the function opens downward or opens upward. And the second derivative test. It tells us where the local max, local min, if there is a critical number. If there is no critical number, then there is no max min. But if there is a critical number and the function looks like this, the critical number must give a maximum. And if there is a critical number in this area where the function opens upward, the critical number must be a minimum. So, and this is called the second derivative test. So I'm going to write it. So I'm on page 4. Any questions for me, please? So second derivative, number 1, gives inflection points. F double prime of x equals 0, and it changes sign. If it doesn't, no point of inflection. Number 2, concavity. The second derivative positive, the function is holding water. Second derivative negative, the function is not holding water. And finally, number 3, the second derivative test. So the second derivative says, second derivative test says that if the second derivative at C is positive and C is a critical number, then C gives a minimum, local minimum. And the other one, second derivative at C is negative, and C is a critical number, then C gives or is a local max. Again, the reason why I'm not using it is because I don't want to get to the second derivative and say, oops, my first derivative is wrong. So I'd rather make sure that these two rows go well together before I even think of the second derivative. But you don't have to use that. It's up to you. You develop your own style. Okay, moving on to other problems. If you'd like to choose, I would like to complete the table again on any problem. We're not ready to graph. We have other things, not yet. So I just want to discuss the first and the second derivatives and create the table, and then we will surely, and not long from now, we're going to graph it. Yes, please.
Number 14.
Number 14. Okay, it's still a polynomial function. I think we should move on from polynomials, but let's do 14 first. That's fine. And then I'd like to choose something else, other types of functions. I'd like to show every type. So 8 over 3 x cubed minus 2x plus, I think it's 1 over 3. Yeah. Okay. So I'm going to get the table going. F prime, and then f of x, and the second derivative. Now, we are missing few things here. That's why intentionally I don't want to graph till we have all the information. For example, here I did not present the x and y intercepts. I will not be able to graph without finding the x and y intercepts. We did find the y-intercept, but not the x-intercept. So there are other things that we have to add to the table. But for now, I just want us to understand how the first and the second derivatives influence what we know about a graph. Okay, so of course it's another polynomial. I have no problem there. I will find the limits here. When I plug in 0, I know I get 1/3. At least that I can find immediately. And we want to find the critical numbers, etc., etc. So I want to find the end behavior first. So limit as x approaches infinity from 8/3 x cubed minus 2x plus 1/3. If anyone can give me that, and then when x approaches negative infinity, 8/3 x cubed minus 2x plus 1/3. I am very proud of this table that summarizes everything. I will not take credit as I promised. I was taught this way, and I wish it were my invention, but it's not. And the way the book is presenting this, I think it's a joke, in my opinion anyway. They are just throwing something in there, and it's just, as I said, I think it's a joke. Okay, can anyone give us these two limits? Anyone? Anyone? So at infinity, the most powerful is the first term. The other two don't even count when it comes to infinity or negative infinity. So what will be the answer here when you plug in infinity in the first term? Anyone? Is anyone there? Please. Anyone? Anyone? Please. Okay. Okay, well, I'm hoping somebody is listening. Okay, so at negative infinity and infinity. And now I will find the first derivative and then the second derivative. So the first one is bring down 3. So this is 8x squared minus 2. I will set it equal to 0. F prime of x equals 0. And I get that 8x squared minus 2 is 0, or x squared equals 1/4. And I'm hoping you remember this. Plus or minus 1/2. So negative 1/2, positive 1/2. And when I study the sign of the first derivative, when I plug in 0, I get negative. And when I plug in 10 or negative 10, I will get positive for sure. Now I have to plug these values in the function, positive 1/2 and negative 1/2, to find the y coordinate. So in y equals, and I have 8/3, please put it in parentheses, and then x to the third power, minus 2x, and plus 1 divided by 3. And then second and graph, I want negative 0.5 and I want 0.5. Negative 0.5 is 1. And the other one is 1/3. Any questions so far? Any questions? Negative 1/3. Negative 1/3, yes. Okay, so now I'm trying to, this is the moment in which I may try to make sure that these two rows go well together. If they don't, I'll say whoops and go back right away. From negative infinity to 1, this obviously is increasing, and the first derivative supports that. From 1 to 1/3, the function is decreasing for sure. From 1/3, and this is supported by the sign of the first derivative, from 1/3 to negative 1/3 is definitely decreasing. But from negative 1/3 is positive to positive infinity, it's increasing, and that's supported. So a sigh of relief, these two work well together. Moving on to the second derivative. Oh, no, not yet. Obviously local max because of the sequence, local min because of the sequence, and because it's a critical number. Okay, so the second derivative, where are you? First derivative here. So the second derivative will be 16x. So this is 0 when x is 0. 16x when x is negative. 16x. Oops, yeah. So obviously this has to be a local max because the function is opening downward and there is a critical number, very clear. This 0, 1/3 is an inflection point. And this will be a local min. The function opens upward and there is a critical number somewhere in that area. Any questions? Any questions? Okay, Would you like to choose another function, or we move on to a word problem? And also, I would like to look at an application of an example of a function that fulfills given conditions. Anyone else would like to choose another function, not polynomial? Or I will. On page 218, would we like to choose a rational function? A radical function? These are the functions that I see here in the book. Either rational or radical. Which one? Which one?
Can we do 42?
42 it is. We have f of x equals x, the square root of 4 minus x squared. Very good pick. However, this requires a lot of work. Even for finding the domain, this requires work. How do I find the domain of this function? What do I have to write? Some of you had difficulties with this function on the test. I wasn't expecting that, and I'm hoping that you are going to look at the solutions line by line. So can anyone tell us the starting point for finding the domain of this function? What do I have to write in order to find the domain? Anyone? Many of you did this problem in on the test, on the midterm. So what do I have to write? Can anyone help?
4 minus x squared should be positive.
Thank you very much. Or 0. Good. So this condition will give us the domain. Thank you so much. So I have to address this first because I don't know what to plug in here. I cannot just go blind. So 4 minus x squared greater than or equal to 0. Do not try to take square roots from an inequality. We talked about that. So I will multiply first by -1. So I have x squared minus 4 less than or equal to 0. I will factor. And we had a table for studying the sign of an expression some time ago. You don't have to use this table if you don't want to. You have other ways. You can plug in numbers. It's easier for me to explain. And I am always using this method myself. Good. So this is 0 at -2, and this is 0 at 2. And I will signify the fact that they are 0 at -2 and 2 respectively. And so is the product. If I multiply if any of these factors is 0, then the product must be 0. Luckily, both expressions have a positive slope, negative to positive. So that's what I'm going to fill in right away. I don't need to plug in any numbers. I multiply two negatives, I multiply a negative, I multiply two positives. But this says negative. Ah, this is the negative, and this is the domain. -2 to 2, and that's it. Nothing else. So I go back to my table, and that's all I can put in. And nothing else. Okay? This is my starting point. That's the domain. Yes, 0 has to be in the table. And of course, when I plug in 0, this will be 0. I will have to plug in -2 and +2. So 4 minus 4, either this or this, it doesn't matter, is 0 times whatever is still 0. And now we're ready to look at the first derivative, which is a mess because it's a product. And I have to be careful with that. So the first derivative first function prime is 1 times the square root plus the first function times the square root prime, which is 1 over 2, the square root of 4 minus x squared, and multiply by negative 2x. And yes, I will simplify this 2 with this 2. I will find the least common denominator, which is this. I will have to multiply this by the square root of 4 minus x squared. So this is 4 minus x squared. Let's see what is left here. I have a negative x with an x because 2 is gone, and there is a negative x times x, negative x squared. So I have negative 2x squared plus 4 over the square root. Yes, you know me, I'm going to factor out negative 2, of course. And then the top is x squared minus 2 over the square root of 4 minus x squared. This is not an easy problem, as you see. Yes, it has critical numbers coming from f prime being undefined. F prime of x being undefined, yes, at negative 2 and 2. Undefined. Undefined. And it can also be 0. So f prime of x is 0, means the top is 0. A fraction is 0 only when the top is 0, which means x squared equals 2, and I take the square root. So x equals plus or minus the square root of 2. These are critical numbers. And these are critical numbers. 4 critical numbers. So now I have to study the sign of the first derivative and also determine these values. So when I square this, I get 2. So 4 minus 2 will be 2. The square root of 2 times negative the square root of 2 will be negative 2. The square root of 2 times the square root of 2 will be 2. Or you can just plug it in the calculator. So now I have to make sure that these two work well together, but I have not studied the sign of the first derivative. Okay. So here's the first derivative, and I will cover up what I will not use in studying the sign. It's a waste of time. This is always positive. I don't have any business to plug in there anything. And this is always positive. I don't have any business in plugging in there anything. So